Hello everyone, and good day to all of you. Thank you for joining this session. The whole idea with effective usage analysis is to perhaps claim that it is possible to accelerate product releases significantly. Modern software applications have thousands or can have thousands of dependencies, direct dependencies, indirect dependencies between open source components and proprietary code. And the software components are occasionally riddled with vulnerabilities that can pose a serious risk to business, to end users, and to the business clients in general. Now, our study that was based on the review of hundreds of projects across a multitude of programming languages revealed that a large portion, and that is pretty significant, a large portion of the reported vulnerabilities in open source components are in fact inaccessible from the proprietary code of the respective projects. And that is another way of saying that they are harmless, effectively, and they could otherwise be known as ineffective vulnerabilities. Now, organizations typically establish the urgency of handling their vulnerabilities based on based on the reported severity of the featured code vulnerabilities. But in light of the number or the claim number of ineffective vulnerabilities, one can contend that developers and AppSec personnel are very likely investing and spending an inordinate amount of time over vulnerabilities that probably shouldn't have been prioritized in the first place. So in this session, we will embark on a journey to review an analysis approach that facilitates the identification of effective and ineffective vulnerabilities, and it helps accelerate the release of solutions in a dramatic way. So our main items for this presentations are to consider the challenges that concern security vulnerability handling in general, then move to something that at present may look a bit amorphous: vulnerabilities versus risks versus something that is called effectiveness. And then we'll get to the point where we discuss what is effective usage analysis, or analysis of effective usage, if you will, and focus here on technical facets and some case study highlights. But let's start with a question here. Most would consider the grand goal of accelerating product releases to be something of an uphill battle. And even though the person here on the screen, the depicted image looks a bit clueless, I think that part of it will actually come into play as we move on through the presentation, and you'll figure out how actually a system may be provided with a lot of cues to direct you in the right direction. It starts out with increasingly tighter application release schedules, which is another way of saying that there are some incongruent elements that such as the business directives on one hand and the pragmatic requirements on the other hand, that simply need to find a way to coexist. And this is not simple, especially when there is a large and increasingly larger number of security vulnerabilities reported for open source component versions used by the applications. Now, agility, business, and scalability are unfortunately not abating. They are not being suppressed, at least not quickly enough. And so what we end up seeing is something that might appear as an unsettling sensation, where our thoughts about how we could actually address those issues are basically even increased in their nervousness. Prioritization would appear to be one of the typical approaches to deal with such a thing. And prioritization is a great thing. In fact, right now, I believe that most of the parties dealing with vulnerabilities are not even deluding themselves that it's possible to address all of the vulnerabilities. They're more likely to say we need to prioritize them. We cannot deal with everything. It's just This is just a matter of fact. So let's do the best out of it. And let's make the best out of it. And prioritization makes perfect sense. However, prioritization is often not a trivial thing. And it's not trivial basically because of three fundamental things. One is that many organizations, I'm not going to claim the exact number, even though I personally have a pretty good idea based on my experience how low that number would look like, lack of structured prioritization approach. Prioritization is not just a gotcha. It's not just something that, yeah, you deal with that and it happens to be this way or another way. It needs to have a process. It needs to abide by certain things. And in many cases, prioritization simply does not follow them. If you look into the way organizations are carrying it out, even though it might apparently look at first as being a process. Why is that? In my opinion, when you look at the way prioritization is applied, in many cases, it does not really factor the appropriate prioritization factors. It may, for instance, factor how old the vulnerability is. I would not even bring this up as a question, even though I did so in the past, and I was alarmed to find out how many organizations consider that to be a viable question. More organizations will likely consider the serious and real question, which is how severe is the problem at hand? A more significant question would be, how does that affect my critical resources in the organization? Does it even affect them? So now you get to already understand where I'm heading at. It's not just about some factoids about the vulnerability. It's about asking how it comes into play within your environment. And the subjective justification of prioritization is what I basically refer to as having multiple parties, each shouting, sometimes really shouting, why they think that their preference makes more sense than the others. One must come up with something that is an objective way to justify how we can run very good prioritization. And the question is vulnerability equal to a risk? Some might say, yes, why not? They stand for similar things, right? I would actually contend that this is not so. Vulnerability stands for something that is, well, at least if you take my particular articulation of that, it's a way to define something that may happen, potentially. A risk is something that is more tangible. Right, this is my particular approach to that. But bear with me for a moment. Let's just assume, what if over a certain percentage of the vulnerabilities, reported vulnerabilities, do not end up being actual risks that need to be remediated? Think about that. And whatever the answer is, based on whatever number you decide to place in those placeholders, this will really accompany us throughout the rest of this presentation. My argument is that an application that features an open source component with reported vulnerabilities, that in itself does not imply that OSS vulnerable code is necessarily accessible by the proprietary code within that project. Please let me reiterate that part because it's significant. We're not saying something about the vulnerability. It is a reported, valid, bona fide vulnerability. It may just not be approached in a manner that really brings up risk here. And the end result or the byproduct of that statement is that such code may or may not pose a real threat. And the way it will do so, and our final conclusion will be based on the way the application's proprietary code is implemented. I would like to introduce the term vulnerability effectiveness. And it really stands for saying that some vulnerabilities are more critical than others. Let's say for a moment that vulnerable code, open source vulnerable code that is accessible by proprietary code poses a threat, and we will thereby deem it as effective. Whereas, conversely, vulnerable code that would not be accessible can be deemed ineffective. And the claim is that many reported vulnerabilities in a given application, and this is the key part here, I would accentuate that multiple times, in a given application may concern ineffective cases. What does effective usage really mean? The analysis of effective usage is really about that. It's not the effectiveness of usage analysis, it's the analysis of effective usage. how effective is the way that the proprietary code reaches code that is noted, reported to be vulnerable. And there are three parts to it: the vulnerability identification and its placement, the way one could reach or access the vulnerability, and how effective would be the severity associated or the risk with that particular reported vulnerability. So let's look into the following depiction. And hopefully the portrayal will not only make perfect sense, but would really carry you through the process of realizing how this could be of value already within a given environment. The basic idea here and the premise is OSS components might have reported vulnerabilities. It goes for a given version. And obviously, whenever there is a report of a new vulnerability, there are many chances that you will have already a fix. But running those fixes immediately might be something that you may not necessarily elect to do for a variety of reasons. So on the right-hand part, you see we have two components, C1 and C2, each with their own corresponding CVE. Just for the sake of example, CVE1 and CVE2, those being open source components with reported vulnerabilities. We have no idea, by the way, where precisely within that code lies the vulnerability. That is probably at the moment of no significance, right? Because we would say it has a vulnerability. That's really what matters, right? Well, the argument is slightly different, as you will see in a moment. Vulnerability effectiveness is really about the way open source code is accessing or being accessed by proprietary code. And in fact, the real reason here is that you can actually ask not only how it is being accessed, but whether it's accessed in a manner that could turn the vulnerable code into something that is exploitable. So it's not just about accessing it. It's about, based on the way you are accessing it, does it pose any risk? And that's why I placed a pronouncing a kind of a rectangle over the connection. But if you look only at this slide, you would say, well, if I know what the dependencies are, I would be able to construe the understanding whether or not the vulnerability being reported is, in my vernacular, effective, right? Well, it's a bit more complicated than that, actually, but in a good sense, because it's critical to establish the relevant open source code which is affected by reported vulnerabilities. And as it so happens, when we're talking about components, open source components, we're talking about pretty large bags in certain cases. They might have in numerous functionalities, so only some of which we may be interested in using. So why just apply the full understanding of having a vulnerability on top of all functions, rather than just say, we would like to understand precisely where the issue arises from. Now, in some cases, you will have information referencing that from the details provided from a vulnerability. But this is not necessarily going to the point where you are able to establish the direct fingerprint of that vulnerability. And that is not just critical, but it makes abundantly clear the sense for running the next phase process, which I will get to in a moment. So the first thing here is about saying within the components, C1 and C2, where exactly is the vulnerability? And then at that point, we can run the next step of analysis that looks very deeply into both the proprietary code and the open code or open source code in question, and figure out whether or not those areas that were highlighted to be associated with the vulnerability are being accessed, and in what particular way, because a particular access approach might not necessarily indicate that there is still a risk. As you know, there are many approaches where the implementation of a given function, here in this case depicted by F1, 2, and so forth, could run. So just for simplicity, you see here F1 to F4, and each of them is marked as if this is a full chunk, either vulnerable or not. And the purpose being that here we would like to make a very conscious decision that if it doesn't touch upon F2, it means that F2 is okay. The same goes for F3. But you can take that example and even dissect it into smaller granular pieces, and then say that within the function, you would actually like to see if there are certain areas that warrant a more detailed inspection. So you get the idea here, hopefully. And as you can tell, the significant part here is, number one, running a vulnerability analysis process, and number two, figuring out how that vulnerable code is being used. And the ultimate result here, and our conclusion, is that one of those cases, the one that is with C1, is deemed effective, because here the code from the application proprietary code, it reaches, it accesses F1, which has a reported vulnerability. And for the sake of this example, this is the granularity. However, when we look at the bottommost call made from the same application, we can see that even though C2 is in general with a vulnerability, the call does not go to that area that was considered a vulnerability, and therefore it is deemed ineffective. So that was a nice way to look into it. But as you can imagine, there is much more detail, much more technical things that are both interesting, but are both also important to understand what is the realm and purview of the issue and how it could actually come into play. So corresponding to the topics that were mentioned earlier, we have vulnerability analysis, code analysis, and risk analysis, all of which together collectively serve to be under the basis of a concept called effective usage analysis. So vulnerability analysis is about pinpointing the location of the actual code within open source which has a problem. And once that is done, it is expected to be captured, recorded within some form of a data store, along with the fingerprints that would allow the next phase, bear with me, to find out whether or not the code from the application actually leverages or avails themselves of that code in a manner that would be alarming. When we move to code analysis, we will see actually three facets. These are essentially the three facets of code analysis that, to be honest, are not necessarily just associated with this particular code analysis thing, but they are very important in the context of effective usage. One is coverage. We will deal with that in a moment. Special language facets. These are different things. One would be the analysis approach and how wide the coverage would be. Another thing is, are we covering multiple language? It's not a product question, by the way. Some may think languages, well, we can have it for one language, for two language. That's not the idea here. The idea is, as you perfectly well know, many applications today are basically comprised of multiple languages. So, and different constituent parts of the application may be captured in different code bases. So being able conceptually to run a process that would be able to analyze multiple languages is of significance. It could be, and it happens to be, part of what the overall concept is really all about. Maximizing analysis accuracy is significant here, and the terms that are being used here should not be unfamiliar. We're talking about false positives versus false negatives, and as probably most, if not all of you know, it's the idea is not to attempt to realize both maximize false positives and maximize and of course optimal false positives and false negatives, which is the optimal way is zero. This is unattainable, but one must reach some concessions, and the concessions would be to maximize the value by deciding whether or not you want to opt for coverage, accuracy, and to run it at a way where the balancing would provide you with as much possible value that you can hope for. And the detection granularity is the pinpointing of the relevant lines of the vulnerable code and the one within the application. I actually jumped, let me go back for it just for a moment, scale. Any of what was mentioned here would be simply irrelevant if it would end up calling for an analysis process that would take multiple days, or in some cases, even a number of hours. Being able to accommodate large code bases within the time developers are expecting to move to their next phase is absolutely one of the givens of considerations for code analysis. So now let's get to some more technical stuff. The application proprietary code and the open source part are depicted here in a manner that actually does not do justice to open source, because open source, in fact, is in many cases much larger in its purview, some claiming to be 80%, in many cases even more than that. But let's do with the example over here. The idea underlying this example is, as you can see, in contrast with a very simplistic one presented earlier, here we have multiple levels of dependencies. And the key idea here with regard to coverage is how well does the analysis encompass open source? So one way is to say that we are actually looking only at the direct dependencies. Some would also claim that this is myopic because there are obviously many issues potentially lurking within those elements that may not be reviewed as part of this particular approach, which is why it is most commonly recommended to look at a larger coverage where you can actually encompass the full complement of open source components, but which in turns warrants inclusion of several analysis approaches, such as interprocedural analysis, along with the intra-procedural analysis that goes without saying. But there are other aspects here of importance. Languages also have their baggage of issues, or perhaps considerations and challenges. One is that one language is not the same as another language. They have very different ways, aside from attempting to translate whatever ideas you have in your head into something that could be carried out programmatically. The way those things are put into place are very different. And the amenities that are featured within each language are extremely varied. So for instance, reflection would be one case where if analysis would not consider it, it would probably totally change the way that the results should be assessed by the end users. And obviously they would also potentially make them incorrect. The same goes for frameworks. The framework concept changes the whole workflow of the application. So we're no longer looking at calls made directly necessarily from the application code to the components, but because we have frameworks change the process, change the workflow, and those things need to be featured and factored as part of the analysis process. It's extremely important to keep in mind that whenever we want to apply the key areas of analysis, one needs to fathom those areas as well. Now, the question would be, how well does analysis detect vulnerabilities and avoids erroneous findings? And this is the accuracy thing. Here we go back to the point where we mentioned earlier that the meticulous, painstaking investigation that was run earlier and places the information of the findings within some kind of data store is now inspected. It is extracted by the analysis process, at least in theory, with the idea of being able to tell, following the analysis of the code base, whether or not you're actually not only accessing the point of the vulnerability, but how exactly are you doing so to figure out whether or not that should be a source of a concern or not. And some of the terms here are probably straightforward and self-evident. This really goes to the detection of vulnerable code and also making a distinction whether or not it is effective or ineffective. But what I would like to highlight here is actually what is even more important. Not just showing what is effective, because that would be something very, very important, by the way, don't get me wrong here. Being aware of the elements that are truly effective is a significant achievement. But so can be said even more so about those elements which are not, and can be proven not to be effective, which are the ineffective items here. So by being able to subject the code of the open source and the proprietary code to analysis that would guarantee 100% that whatever is marked as ineffective is indeed so, that will allow you to put it aside and to lower dramatically the number of items that you need to deal with. This is where we get to the area of prioritization, which, by the way, at this point is still not prioritization. It's about moving aside those items even before you start with prioritization because you don't want to deal with them. So you reduce your the overall work pretty significantly. However, those elements that are retained following this step are those elements that are associated with the third part of usage analysis, which is the risk analysis thing. And here you can take whatever elements that would be considered theoretically in a solution, such as business impact, reported severity, whatever else options you have in mind, and then apply them to those elements that were found to realize what is truly and utterly the severity which is effective. And this is really what the whole idea behind this is all about. Now, it would only be sensible at this point, following especially the earlier slide that asked the question, what if? So we ran a process where hundreds of real-world projects were put to test, and I think that you will find the information enlightening. So the number of, or perhaps more importantly, you can look at the number below. I think it speaks for itself, but a significant amount of reported vulnerabilities, in this case for Java, but it is interesting to review the results for other languages as well, were analyzed and found to be ineffective. Now try to apply this number, and you know what, be even forgiving with regard to that number, even though I can tell you that theoretically, the number could be even higher than that. But let's even say, for the sake of example, that you would even reduce it by half. Who would not consider a way to just ditch some of the elements that are currently garnering the focus of developers and may not necessarily require attention from a remediation perspective? This is really what this idea is all about. And this is the potential and the concept of effective usage and the analysis of effective usage. The business angle of this can be proved to be extremely valuable. And you can see here just but 2 points that give you some food of thought. Maximized AppSec team productivity. You have more time. You have more time to dedicate the effort on areas that concern productivity. Another thing is maximize time for handling, forgive me for saying, the real vulnerabilities. Of course, all of the vulnerabilities, including ineffective, are real vulnerabilities. Let me just stress that. Should there be a single change in a line of code, it may or might, depending on the way you look at it, render what was the early result from the analysis no longer applicable, because at that point, that change could render what was previously an ineffective vulnerability to turn it into an effective vulnerability. But that's the power as well. That's why I emphasize so many times the notion of within the application, within the context of the application, and why the effectiveness is so significant here. Again, I would be amiss if not mentioning the facilitated remediation. One could say, isn't this enough? Well, no, not so. If you need to go from this point to remediation, what's more than just asking, I would like to know exactly what I need to deal with. So one of the byproducts, one of the derivative benefits of a technology that promises such things is the ability to pinpoint exactly where is the culprit in the code. So not only is it possible to identify a vulnerability as being effective or ineffective, but the information that could be provided to developers is here is where you need to look at. Here is where the call is made. Here is the trace that leads to the issue of problem. So this is information of significant value. So to summarize the probably quite a few topics that we covered as part of this session, the analysis of effective usage truly facilitates, is believed to truly facilitate the classification of critical threats, but importantly, it manages to improve also prioritization. The effective usage analysis itself is not a prioritization per se, but some would argue that the concept is even better because it moves aside things that are not germane to the process of remediation. However, it does leave elements that when factoring the third part of effective usage, which is the risk analysis, do end up providing the means for effective risk-based remediation and, of course, prioritization. Analysis of effective usage can also go a very long way towards eliminating efficiencies. And those efficiencies concern ineffective vulnerabilities. And finally, analysis of effective usage can help organizations realize better scheduling goals via better utilization of resources. Thank you very much.